Welcome to this detailed walkthrough of the Campus Recruitment Salary Prediction Project. This is an end-to-end machine learning and Flask-based web application designed to estimate student salary packages. It predicts salaries based on various academic and personal attributes, offering a comprehensive solution for campus placements. In today's competitive world, companies analyze multiple factors before deciding compensation during campus placements. This project simulates that real-world scenario using data-driven insights and advanced predictive modeling techniques. In campus recruitment, thousands of students apply, each with diverse academic backgrounds, streams, skills, and work experience. They also have varying test scores, making manual salary prediction challenging and highly subjective. This project solves that problem using machine learning, enabling educational institutions and students to estimate salary outcomes with high accuracy. Let's talk about the dataset used in this project, which is crucial for accurate predictions. The dataset, named train.csv, contains rich information about students, including their gender and secondary school percentage. It also includes secondary school board, higher secondary percentage, and higher secondary board. Further details include higher secondary stream, degree percentage, and the specific degree type. Work experience, employability test score, MBA specialization, and MBA percentage are also key features. Finally, the dataset contains placement status and the salary variable, which is our target for prediction. These features help us understand how academic performance and skills influence salary predictions in a data-driven manner. Before building the model, an extensive exploratory data analysis, or EDA, was performed. We visualized score distributions, compared placed versus non-placed students, and analyzed various trends. Some interesting insights emerged from this analysis, providing valuable context. Students with work experience tend to receive higher salary offers, showing the value of practical exposure. A strong correlation exists between higher academic scores and salary, emphasizing the importance of scholastic achievement. MBA specialization and employability test scores significantly impact the final package, highlighting specific skill sets. Such analysis helps us understand the dataset deeply and prepares us for robust modeling. The next crucial step in our process is data preprocessing. We handle missing values, remove unnecessary columns like SL_now, and apply one-hot encoding for categorical variables. Categorical variables such as gender, board, and stream are converted into a numerical format. All numerical values are scaled using standard scaler to ensure uniformity during model training, preventing bias. This step is crucial for improving model accuracy and stability, leading to more reliable predictions. For the modeling phase, various algorithms were tested to find the most effective solution. These included linear regression, lasso regression, random forest, and gradient boosting. To find the best performing model, we used grid search CV combined with shuffle split cross-validation for rigorous evaluation. After rigorous testing, the ridge regression model was selected due to its excellent generalization ability. It also offers stable predictions and the ability to handle multicollinearity among features effectively. The model is trained, evaluated, and saved as model.pkl, while the scaler is saved as scalar.pkl for deployment. To make the system user-friendly and accessible, the model is deployed using Flask. This creates a smooth and interactive web application, providing a seamless user experience. Users simply enter details such as gender, scores, and academic stream. They also input work experience, test scores, and MBA scores. The application then instantly predicts the expected salary, providing immediate feedback. The interface is clean, modern, and easy to integrate into college ERP systems or student portals. For example, if a user enters academic and personal attributes into the form, the backend processes the inputs. It scales them and passes them into the model, ensuring consistent data handling. The model returns the predicted salary, which is then displayed on the results page. This real-time prediction capability makes the project highly practical and industry-ready for various applications. The technology stack used in this project is robust and modern. It includes Python 3.11, Jupyter Notebook for EDA, and Pandas and NumPy for data processing. Scikit-learn is used for modeling, and Flask is utilized for deployment. A Bootstrap-based UI ensures a clean user experience, making the application visually appealing and functional. This combination provides a powerful and scalable environment for machine learning application development. This project can be used in multiple scenarios, offering broad applicability. Colleges can use it for predicting student placement salaries, aiding career guidance. Students can understand their expected compensation, helping them in salary negotiations. Training institutes can build career analytics dashboards, providing valuable insights. Recruiters can analyze candidate profiles more effectively, streamlining the hiring process. Developers can learn end-to-end ML deployment, enhancing their practical skills. The project is practical, real-world applicable, and perfect for resumes, academic submissions, and portfolio building. To conclude, this campus recruitment salary prediction project demonstrates a complete machine learning lifecycle. From dataset analysis and model creation to deployment and real-time predictions, it covers every essential stage. If you're looking to learn ML model deployment, explore data science workflows, or build a strong academic project, this is a perfect example. It represents a professional, industry-style implementation that is both insightful and practical. Thank you for watching this detailed explanation. Feel free to explore, customize, and enhance the project further.